Thank you for joining this lesson. We're going to discuss rates of work and proportions. Two pipes, P and Q, can fill an empty tank in 3 hours and 4 hours respectively. It takes 5 hours to fill the tank when an outlet pipe R is opened at the same time with the inlet pipes. Calculate the time pipe R takes to empty the tank. Remember to subscribe to this channel and to also share the link with friends. Let us begin answering this question. We know very well if P takes 3 hours to completely fill the tank, then it means in 1 hour for P, it fills a third of the tank. That is why it would require 3 hours to completely fill the tank, because when it fills a third in 1 hour, a third in the second hour, then the last third in the third hour, we will have the tank completely filled. Then in 1 hour, Q is going to fill 1 out of 4 of the tank. This is because it requires 4 hours to completely fill the tank. So it means in 1 hour, it fills a quarter of the tank. Again, there is now an outlet pipe, which we don't know its rate of work. So we can say that in 1 hour, the outlet pipe now, which is R, empties a fraction, which can be let to be 1 over x, of the tank. 1 over x of the tank. But now when they are combined in 1 hour, the combination of P, Q, and R, because they fill in 5 hours according to these instructions, then it means they are filling 1 out of 5 of the tank when they are operating together. 1 out of 5 of the tank, because they are all requiring 5 hours to completely fill the tank. So now we can talk about 1 out of 3 plus 1 out of 4. Now we're going to have a negative the other fraction. Actually, instead of having 1 over x, we can let the fraction be x because it's unknown. When we subtract the fraction which is being emptied in an hour, we can let it be x instead of 1 over x. So this fraction is let to be x, the fraction that R is operating at per hour. We're going to get 1 out of 5. This is when the 3 are operating, when the 3 taps or the 3 pipes are working. This is P, this is Q, and R, which is emptying. It is emptying a quarter. So we can get now our x, and to remain with x, we can have it to the right hand side being positive. Then we bring the other fractions together. 1 out of 3 plus 1 out of 4, then minus 1 out of 5. So the value of x equals to, when we take a third and we add a quarter, then we subtract a fifth, we're going to get 23 out of 60. So if this outlet pipe can empty 23 over 60 of the tank in 1 hour, this is in 1 hour, that one should be understood that it is in 1 hour, then it needs time, which is equivalent to the reciprocal of this fraction. So time required would be 60 over 23 hours, which is going to be 2 and 14 over 23 hours. So this is the total time required for pipe R to completely empty the tank when operating alone.